Okay. Now we will start a new topic today about the IoT architecture. Okay. In the first class, I introduced the IoT, talk a lot about the application. We continue to talk about the application. In my opinion, when you understand the application, you can have a real understanding about what IoT can do. Okay, there are different ways to see IoT, but in this course again, you didn't have the network course. Okay, the focus here is more related to the application. We discuss about the network, but you develop on an IoT application. Okay, we put more focus in the application layer than to the network layer, but we'll discuss network layer in the next class. So today, the goal is introduce to you the different types of IoT architecture. Okay, you see, for example, questions related to the edge, to the cloud, how these things, which functionality you need to have in each layer that I present to you. The first point is, what is IoT? I revisit this point because sometimes, or a lot of times, our understanding about IoT is a little concentrating in a particular layer. IoT is much bigger than it. Okay, so IoT is another view. IoT is an advanced automation and analytics systems which deals with artificial intelligence, sensor networking, electronic, cloud message, and the others to deliver a complete system for the product or service. The system created by IoT has greater transparency, control, and performance. I really like this definition because this definition is not in the network layer, but is in application layer. When you see this definition, you think about these main topics. For example, advanced automation. IoT, if you remember the Nissan case that a lot of students work in this scenario, in the Nissan case is an automation, use IoT to automate things, okay? And to automate tasks that in the past you need to use human to do. The second point is analytic systems. It's more related to the city, I believe is a city case. I cannot remember the place, but I believe it's in New Waves, if I'm not wrong. It's more related to analytic system. You collect a lot of data, process this data, aggregate this data to generate useful information. Okay? It's not so related to the automation, but it's related to get data and transform in useful information. Okay. Who enabled this type of things? Artificial intelligence. Artificial intelligence is a discipline that is completely related to IoT, because different than the past, you have a lot of data to handle. You need to have use artificial intelligence, for example, to aggregate this data, to correlate this data, to process this data and to find information in a big data or a lot of data. Sorry. Another one, sensor. Now today it's so easy to have a very advanced device with multiple sensors, like for example your smartphone. Your smartphone is a very complex IoT system because you have accelerometers, you have temperature, you have interface, you have a lot of information that is available in the smartphone. It's a very powerful. You have other device that don't have other device that do not have a lot of sensor information. Is more simple. But the sensor capacity is an enable of the IoT. Networking, again, now you have sensors installing everything. Your refrigerator, your air conditioner, your cafeteria, all of these devices that in the past does not provide any information, now produce a lot of data. And to support the application, this type of application, you need to have bandwidth. You need to have new network protocols that enable new network medias that support a large bunch of data. Electronic and cloud message. Another thing that is the place where this device is. For example, I have one device here, one network, for example, Google. The Google has device that send information to share data with the cloud. Things that in the cloud does not exist like in the past. You need to have an architecture like a client server that you need to install servers around the world. Now it's not required. You can install the servers inside the cloud, and it's a real transparency where the server is now. You only provide connectivity to devices around the world. Okay, it's what is IoT. Do you have any questions about what means IoT? Or no questions?
Nope.
No.
Okay. So, why do I need one architecture? To think about the complex system is very difficult to think like in the past that you need to think the block. Think, for example, a car. When you think about one car, you think, oh, a car has wheels, a car has engine, a car has air conditioner, a car has airbag and others. It's like, for example, think about us, our body. When you try to understand how the human works, you divide the human functionality by specific functionality. For example, the C system, the brain system, the walk system, in the others, for example. Okay. It's a good thing when you design any system. It's a good thing to divide the system in the small blocks and try to explain the connection one block to other. It's the same in IoT. In IoT, you have a small device like my smartwatch. If you want, for example, think about explaining one IoT system to take about the healthcare. You can divide in the small piece the healthcare system. For example, one piece is the smartwatch that measure your health condition. The second layer, you can have the device that collects this information close to the user and send to the central system. Another layer is the central system. And you can divide the central system, for example, the subsystem that aggregate the information, the subsystem that correlates the information, and the subsystem, for example, that process the information and generate intelligence. Okay? An architecture is a concept that make this puzzle together, okay, that join these small piece in a integrate piece, okay? You use architecture, for example, to explain a system in a useful way. If you go to the internet, you can find a lot of different IoT architecture. For example, there are one IoT architecture that the focus is in networking, okay? It's a completely different approach. I like this approach because it's more related to the functionality. And in this time, it's very good to understand the functionality. I believe we can discuss about the IoT things only in the functionality, in this layer of abstraction, okay? In this layer, you have a four-stage IoT architecture. The first stage is the sensor actuators, in other words, the things. Is the layer that you have the sensor, is the layer that you have the actuators. There is a difference between the sensors and the actuators. The sensors measure information and send. The actuators receive a command from someone and perform a task, okay? In both cases, it's related to the things, okay? These sensors can be wired, okay, or wireless, okay? This sensor can be a camera, your smartwatch, weather station, and device. But this sensor needs to send the data to the final application that is in the stage 4. Is the place where you have the cloud, the data center, the analytic management. The application is in this layer 4. But thinking about this situation, you have sensors that produce thousands of information by second, and you send all of this information to the cloud. You need the bandwidth that you need and the space that you need to, the bandwidth that you need to transport the data and the storage, the space that you need to store this data is very, very big. It's the reason that you need another layers in the middle. One of these layers is the internet gateway. The internet gateway and data acquisition system has two main tests. The first test is to aggregate data from the device, okay? For example, you have a gateway that organize the data from the device. And this layer here provides a translation of the protocol. For example, this device here is a very restricted device. Don't have a lot of research. Remember, you need to have batteries that work for a long time. For example, my smartwatch is not a very powerful computer. It's a very simplistic. The consequence is this device does not support advanced protocols. The protocols that this device supports is very simplistic. In other side, you have the cloud that supports large transactions. It has a lot of secured implementation, has a lot of power. It's very dangerous to use, for example, simplistic protocol in the application layer. It's very dangerous. You need more advanced, more sophisticated protocols to work here. And how to solve this problem? Because here is simplistic, here is advanced. You can use the internet gateways. The internet gateways, one of the tasks that this layer produces is to translate the simplistic protocols in the advanced protocols. Another one is to provide some internet for the small device. And there is another one that is data aggregation. Remember, here you have, in this layer, you have thousands of information. This data here can aggregate this data and generate some layer of takeoff redundancy, but organize the data to send to the next layer. Any questions you hear, guys?
Yes, for example, what does edge means on HIT? Why is it edge?
Are you explaining? I didn't explain yet. Are you explain the edge soon? Okay. I explained just on this one and this one. Okay. The edge will implement a new layer. Okay. The internet gear is close to the sensor. For example, think your home. Okay. The internet gateway is aggregate the data from your home. For example, aggregate data from the device that you have in your home. In the edge aggregate data close to you, but not related to your home. For example, things that you have, it's very common, for example, in the, oh my gosh, what's the name? In the power grids, okay? In the power grids, very easy. It's very, very common. For example, you have your street, okay? Your street has 4, 5, 10, 20 houses, okay? Each house has your internet gateway. It has your router. But you have in one place in your street one ad device, okay? This ad device concentrate data from the homes in the power grid. And what the ad device does? Remember, you have this device close to you. It's not in the internet, it's close to you, for example, in your street or your neighborhood. This data aggregates the data from because sometimes you don't use the internet gateways. This device can, a lot of times, this device, both device is in one unique device, okay? But think that you have the both. This device can concentrate, aggregate data too, and this device can do another thing. Remember, I'm clear here. Until here, you have a big bandwidth. For example, in your home, you have a lot of bandwidth that your Wi-Fi provide. But here, you don't have, okay? The ad device can, for example, get a lot of data, okay, from the internet gateway and analyze this data and see. Oh, for example, you have a temperature sensor, okay? And receive each second 10 messages about the temperature of one sensor, okay? And the ad device, what the ad device does, okay? Temperature don't change, don't change, don't change, don't change, change. When you change, you send the data to the cloud. If you don't have any change in the data from the gateway, you don't send to the cloud, but you store locally. A lot of times, internet gateways does not have any storage support. You need the edge device to store the data. Another thing that you can implement in the edge device is, for example, to some analytics. For example, think that you have this rule. Okay, if the temperature is below 10 Celsius degree, you perform one test. You can implement this technique or this rule inside the edge device. In the gateway is not possible. Okay? You can implement this rule, for example, in the cloud, but you can implement this rule in the edge layer too. And finally, you have the cloud, where you perform the big tasks because you have a lot of resources. Cristóbal, can I answer your questions?
Well, I still have a little bit of trouble understanding, for example, the difference between edge and the internet gateways. For example, who is the one that filters or says which data goes to the cloud? For example, you said that at some point, if data doesn't change, it doesn't go to the cloud. So it's regarding edge, or it's regarding internet gateways and data acquisition?
In the edge, okay? The edge provide, remember, in other words, you can have simplistic things in the internet gateway. For example, in the internet gateway, you have, give me a second, a protocol translation, okay? Protocol translations, okay? You can do it in, oh, sorry. Here in the internet gateway, okay? Here you can have, for example, smaller protocol translation. Another thing that you can do here is, for example, data aggregation. Things that you receive data and you can aggregate. For example, you have sense one that send data, okay, a lot of data. This device is not it's not common. However, this device can aggregate this data. For example, you send, for example, data from time 0.1, time 0.2, time 0.3, and this data sent to the edge, the time 0 only. Did you understand? It's like the time 0 is equal F aggregate of time 0 sequence. Did you understand or not?
Okay, yeah, it's like an array.
Exactly, but it don't send the array. You have a function that calculates the average. You need to define the function, but you send for example, the average of this data for the edge. Okay. Remember, here you send a data, for example, things that you have in 1 second. You send 1,000 data. Okay, you don't send 1,000 data to the edge. You send one data that you use a function to calculate average or other who. Okay, did you understand?
Okay, now it's very clear.
Okay. However, this function here is not so common to implement here. Okay, but you can have. In the edge is a little different. In the edge, I put here. In the edge, for example, this device here, the internet gate, send one data for second. Okay, it uses a function to aggregate this data. In the edge layer, you can have one function. You cannot send one data for second. Sometimes it's a lot of data to send the cloud. One function that this guy have is a aggregate function too. But you send T0, T1, T2, T3, and send one data to the cloud, not second by second, but maybe 30 seconds to 30 seconds. Did you understand?
Okay, it's like two filters, for example. One, the gateways and data collection and data acquisition collect basically all the raw data, then it is filtered and sent to the HIT, and then it's again filtered and sent to the data center, right?
Yes, yes. It's not, the name is not exactly filter. It's the name is correct, the name is aggregation.
Okay, just like you said, like an average, for example, or
Exactly,
something.
exactly.
Okay.
Or other function, okay?
Okay.
Another
okay,
thing
great.
that this guy does is, for example, you don't use the one aggregation function. This device can do another thing. Things, for example, in the time 0, time 1, and time 2 is the same information. Is the same information. You send to the cloud only the time 0. However, in the time 3, you change the information. Change the info. Okay? You send again the time 3. And time 4, time 5, time 6, time 7, don't change the information. You don't send nothing. Okay? Because you already send in time 3. But in the time 8, you change again the information. You send the time 8. Did you understand? It's
Yes,
more
only
filter.
when
It's a related. The name of it is analytical filter. It's more common to say that it's a filter.
Okay.
Give me a second, just a moment to check one thing. Okay. Okay. So another thing that this guy does is this guy can does, okay? The normal temperature is between the layer 3 to layer 5, for example. Define a threshold, okay? The temperature needs to be in layer 3 to layer 5, a level, sorry, level 3 to level 5, it's okay. Above or below, it's a problem, okay? This guy can measure, he see, for example, in the time 0, the layer is 4. The time 1, the layer is 4. In layer 5, it's okay. And the next layer 6, this guy can generate an alert, okay, and send to the cloud. Did you understand?
Yeah, it generates alerts when there is a change, a specific change, right?
Yes, for example, you define in the ad, for example, the threshold that the sensor needs to work, okay? If the sensor works outside the threshold, you generate an alert to the cloud, okay? It's one test. Another one is, for example, it's the same, but you don't generate the alert. You send to the device intervention. For example, things that you have a device that you need to work in a specific threshold. And you have a measure that, okay, for example, like level 6. Oh, level 6 is a problem. You send an alert to the cloud, but you send a command to the device. For example, turn off the engine to the temperature decrease. Did you understand?
Just the part where I send the alert to the cloud, but you said a command to where? I didn't get it.
Okay. One functionality of the edge is to generate this type of alert. You work, for example, it's the normal function of one device. Okay, it's working things, for example, 20 Celsius degree to 30 Celsius degree is the normal functionality of the device. Okay, and you start to measure this device. Okay, the device send the measure 20, 20, 22. 33, okay? It's normal. You don't send nothing to the cloud. But one time you send 31. When you send 31, you send a message or an alert to the cloud. Okay? Did you understand here?
Yes.
Okay. However, in some device, you remember that I told you that some device is sensors, okay, like you talk here, but has actuators, okay. Think that device that you talk is an actuator, okay. If it's an actuator and the edge has capability to it, the edge can do the same things, okay. You see. Okay, 20, 20, 23, and 31, okay? When you receive 31, you generate an alert sent to the cloud, but you can do another thing. You can send a command to device, okay? You send the command to device, okay, turn off the machine because it's so hot, for example, okay? The directions is not to the edge, to the cloud. The direction is to the sensor or to the device. Did you understand?
Yeah, absolutely.
Okay. Again, you can implement this thing here, but again, sometimes you don't implement it. The edge device is a little simplist. Okay, and you implement these functionalities in the cloud. Okay. In the real implementation, you don't need to have the complete set of device, okay? You can have, for example, you have the stage 2 and stage 3 in the same equipment. You don't have the edge. The edge in the cloud is the same equipment, is in the same place, okay? It's a didactic or academic device, academic explanation about layers, okay? Did you understand?
Yes.
For example, in our, I don't know if it's open. Give me a second. Here, yes, it's open. In our case, the sensor is your smartphone, okay? And the smartphone produces what? The GPS position and the severity of the human here, okay? It is in each layer, guys. Oh my gosh, what's happening? Did you see my screen or not? I believe no.
Yes.
Did you see here my screen?
Yes, teacher.
Yes.
Is the canvas, no?
Yes.
Okay. Okay. Where's my patient? Okay. Using the first stage, which layer it is? Is the sensor and actuator, internet gateway, edge, or data cloud, or cloud? Which layer?
The sensor.
The sensor, exactly. So another one is the gateway, no? The gateway provides access to the cloud. You can implement in the gateway for in the drones, for example, authentication. The drones can, for example, oh, don't change nothing. I cannot send to the cloud. Which layer the drones works? Is in the sensors, internet gateway, edge, or cloud? Which layer, guys? Or which stage?
I think it should be the gateway, but I also think it might be the edge also, or maybe the both are connected.
Exactly. Depend the functionalities that you implement, it's only is a gateway. All the time is a gateway, okay? All the time is a gateway. But if you implement more things, it can be a gateway and an edge, or only a gateway, okay? It's correct. Finally, you have a system that you have where you support the decision maker, no? That has a dashboard with location, the risk, and severity. So, which it's the name here now. It is in the cloud. I believe it is to see, no? It is in the cloud layer. Did you understand the 4-stage layers architecture? Any questions? Any question about it, guys?
Not at the moment.
No, for now.
So the first layer, things, sensors, and actuators. The sensors or actuators are devices that can emit, accept, and process data over the network. If it is a sensor only, it will only send, emit data. However, if it's an actuator, okay, if it is an actuator, it accept and process data, okay? Remember the case of our device that receive a command to turn off, okay? It's accept the command, process the command, and perform one task. This sensor or actuator can be connected using a wire, like a cable, or a wireless channel, okay? Today, all the time, most of the time you use a wireless connection, but you have in the past wired. The device can contain GPS, electrochemical, gyroscope, RFID, and others, okay? For example, it's examples, you can have a not smart sensors, okay? Not smart sensor is the sensor that only send data to the internet. For example, accelerometers, temperature sensor, process sensor, image sensor, light sensors, microflow sensor. It's device that don't have, cannot receive command from the internet, only get some data and send to the other guys, okay? It is no smart object. Another type is the, for example, one example is actuator, for example, okay? That is this one, receive command from the internet. The smart object different can send data and interact with other things. The no smart don't interact with other things. For example, the no smart object send your, for example, collect the temperature and send to one place. Sometimes can receive a command to the other device, okay, from the internet. However, the smart object can interact with other. For example, remember, my smartwatch don't have Wi-Fi interface. My smartwatch talk with my smartphone and interact with my smartphone, okay? Some examples of the smart and those not in no smart device. For example, smart object, smartphones, microcontrollers like Arduino or Raspberry, and robots, okay? No smart is the sensors like temperature and humidity sensor, flame detector, and actuators like servo motors, speakers, vibration, sending mails, okay? One example of the smart object, okay? Arduino device. Arduino is a very small microcontroller, okay? You can use to perform a lot of small tests. Arduino is not so simple to work. You need to understand in particular how the board works. For example, the Arduino you're programming in a language like Python, but you send data, for example, one port to other. You don't work in the very abstract, high level abstraction of commands. You need to programming in a very small detail what you do with data. It's different than the Raspberry. The Raspberry is a small single board computer, okay, but it's a computer that you can use, for example, Python, like you programming in a computer. It's clear you can do very detailed things, but it's much easier to work, okay? The YIPS will work with you using the Raspberry, okay, during his class. I believe, and the after the Semana Tech.
Just one question.
Okay,
We're
go ahead.
using Raspberry, but we are programming it in Python or in what language?
In the Raspberry?
Yeah.
The Raspberry, you can program in Python, you can program in C++, because Raspberry is a computer. The Raspberry OS, you have two operating systems that you can use in the Raspberry. One of them is how I say is a fork or a small version of Debian. Okay, what is a Debian? You have the same thing, most of the things that a Debian has. You know what is a Debian?
No.
A Debian, do you know Ubuntu? Ubuntu Linux? Yes or no?
No, I heard something about Ubuntu, but I haven't never used it or.
Okay, but you listen about the Ubuntu, no? The Linux, on Ubuntu Linux. Ubuntu Linux is a fork of Debian, but it's a fork more powerful. It's easiest to use Ubuntu is easiest than to use Debian, okay? And the Debian is a very powerful Linux distribution. However, the Debian is more secure than the Ubuntu, but there are things that in Debian is more harder to do than Ubuntu because Ubuntu is more user-friendly, okay? It's not like Windows, but it's very close to Windows, Ubuntu. Debian, no. Debian is more close to the original Linux. You don't have the interface, the graphical interface is not so beautiful, it's not so powerful, it's more simplistic. In the Ubuntu, most of the time you use the shell to do the things. In the Ubuntu, no. You can use the graphical interface like Windows to perform the test, okay? The Raspberry has a simplistic, one fork like Ubuntu has a fork to work in the Raspberry hardware. Did you understand?
Yeah, now I understand.
Okay, perfect. So again, the Professor Yepes, Luis Yepes, will work with you in his class using this device, okay? It's not possible to that I teach you about this device because you need to learn a lot of things that the Jose Yepes will teach before the Semana Tech. And we define that we're teaching you about the Raspberry after the Semana Tech, okay? I check if I share the audio. I have a video about the 10 most advanced IoT devices in the world. It's an amazing video because show a lot of ideas of how to do what you can do using the IoT to help people in the common task, okay? Please pay attention. It's a nice video. It's very nice and very fun video.
Welcome back to Emerging Tech, the definitive channel for upcoming technology that will change the world as we know it. If you're a regular internet user, you probably would have heard about the Internet of Things, or IoT by now. IoT simply describes the network of physical objects embedded with sensors, software, and other technologies to connect and exchange data with other devices and systems over the internet. We now have many of those devices in our homes, helping us regulate our room temperature, humidity, door locks, and many more. In this video, we'll look at the 10 most advanced IoT devices in the world. You'll be surprised by what these devices can do, so make sure to watch the video to the end. Number 10. Wemo Smart Plug. Being able to control the bulbs in your house from anywhere goes a long way in ensuring your house's security and lighting, especially at night. With the Wemo Smart Plug, you can now switch on or off all of your home bulbs from anywhere. This smart IoT product provides users the ability to monitor the lighting of their homes remotely. You can create rules, schedules, and receive notifications. The Wemo Smart Plug also gets insights into your home energy usage. You can use it with both iOS and Android devices, and it integrates with Alexa or Google Voice for hands-free control. Number 9. Enerve React. How many times have you forgotten that your food is still on your blazing gas cooker? You probably have washed your burn pots several times in the last few months. Well, many people didn't end up with burned foods, but a burned house. Preventing fire disasters at home and offices is the exact reason Enerve React was invented. Enerve React is the first device that lets you control your stove from your smartphone. Its combination of electronics and sensors enables it to detect high levels of smoke, natural gas, and lack of human motion in the kitchen. This device can react and turn your stove off when you're not near it. Enerve React also allows you to modulate the burner temperature from your mobile device. With this innovative device, you are surely many steps above home fire disasters and burned foods. Number 8. Bitdefender Box 2. The idea of IoT sounds great until you remember that internet-enabled devices are susceptible to hacking. However, with Bitdefender Box 2, you don't have to worry about the security of all of your IoT devices. Bitdefender Box 2 is a security device trusted by many experts and users for securing homes by protecting all connected devices with a single security solution. It plugs into your router and protects an unlimited number of Wi-Fi and internet-connected devices using Total Security Unlimited. This device offers excellent data protection, providing an out-of-the-box solution that gives its users peace of mind concerning their IoT devices. Number 7. The Amazon Dash Button. The Amazon Dash Button is a consumer goods ordering device that uses proprietary devices and APIs to order goods over the internet. This IoT device can remember important household items like grocery materials, soft drinks, medicines, and others. You can place orders for them when their supplies are running out in your home. It monitors the supplies to check the quantities remaining and places an order at the right time. All you need to do is complete the first order. From that point, it will take up fresh orders unless you have authorized it for multiple orders. Number 6. AdhereTech Wireless Pill Bottle. The AdhereTech Wireless Pill Bottle is a drug bottle that can be used by patients in pharmaceutical and research engagements. With this bottle, patients get customized support and reminders sent to their phone via text message or an automated phone call. This bottle automatically sends data to AdhereTech's HIPAA-compliant system, where it's analyzed to determine how to best support the patient. For example, if doses are missed, patients can receive customizable alerts and interventions. Patient responses to the interventions can also be analyzed. Number 5. Picno. Every farmer knows that getting all the data parameters of the soil and the air is important to their farming success. Picno is an IoT device invented to help farmers tackle the problem of food security by building a network of wireless sensors for growers. These simple-to-use and easy-to-maintain sensors measure key parameters of the soil and the air, which are mixed with other regional data to provide users with the best practices on how to be more efficient at producing food. Current Picno users have shown great improvements in the quality and quantity of their harvests, while also reducing the amount of resources such as fertilizers, water, pesticides, fungicides, and electricity that they use. Number 4. Cubic. Have you ever wished that you could connect almost anything around you to your device so that you can easily monitor them? Then Cubic was specially made for people like you. Cubic is an IoT Wi-Fi device that connects your everyday objects and spaces to the web. This 1-inch cubic structure connects, monitors, and reports real-time data on any object, appliance, and living or office space to your smartphone or tablet. This smart device is consumer-friendly, affordable, and has no baseline subscription fees of any kind. You can receive and monitor data on your mobile device using the free Cubic mobile application. Data produced by Cubic is accessible through open source technology. That means developers can build mobile apps that use the data which Cubic generates to build new products. There are currently 4 Cubic devices, including Cubic Temp for temperature monitoring, Cubic Feel for humidity monitoring, Cubic Glow for monitoring light intensity, and Cubic Move for monitoring motion. Number 3. Ring Video Doorbells. When someone knocks on your door and you're not at home, what can you do? Well, almost nothing. But wait, how about you answer the door even if you were thousands of miles away? With the Ring Video Doorbell, you can now attend to anyone at your door no matter where you are located around the world. This device is a reliable IoT product, allowing users to answer their door via video interaction from any place using their smartphone. It will also protect your home with its security cameras and double-clad home network security. Ring Video Doorbells also provide motion detection sensors, and its videos are HD quality. It provides night vision all day long so that you don't have to worry about night vision. It comes with a rechargeable battery and high performance. Number 2. SensiMed Triggerfish. Diagnosis and treatment of vision loss and glaucoma are usually tricky for physicians. This is because these conditions usually require constant monitoring to get an actual picture of what's really happening within the eyes. Optimal diagnosis and treatment of glaucoma is the exact reason SensiMed Triggerfish was invented. This continuous ocular monitoring system is a CE marked and FDA approved device that provides insights into the ocular volume changes throughout the day and night. This IoT device obtains critical information about the eye at any time of the day and sends the information to a physician. This helps the physician in the diagnosis and treatment of glaucoma. Number 1. Abilify My Sight. There have been many inventions for medical practices in the past few years. One of the most notable of those inventions is Abilify My Sight, a drug approved by the FDA in 2017. Abilify My Sight, which is actually aripiprazole tablets with a sensor, is the first drug in the US with a digital ingestion tracking system. This combination has an ingestible sensor embedded in the pill that records if the patient took the medication. For those that don't know, aripiprazole is used for treating schizophrenia. So the need for the tracking system is understandable. With it, patients' adherence can be monitored by their healthcare provider. We hope you enjoyed the 10 most advanced IoT devices in the world video. Make sure to check out Emerging Tech's video on 10 real flying cars coming before 2030.
Okay, what did you think? Did you like it? I really like this video. What you can do everything, no? You need to have ideas, no? There are some ones, for example, the Google button, for example, it's not a real makes sense in Brazil, but in US make a lot of sense. Okay, I don't know in Mexico, but in the US you can buy everything by using the Google, the Amazon button, sorry, and so you can use the Amazon, and this button make a real sense. In Brazil, no. In Brazil, is don't make sense. Okay, but it's nice. There are a lot of sites that you can find ideas how to use IoT to solve problems. I can share a lot of others to you if you want. The next layer is the gateway. Okay, the gateway again provides the bridge between the different communication technology, make translation. Okay, it's the main task that the gateway does. For example, you have device and you have a different protocols in the cloud. The gateway can provide this change. Again, protocol translation, the gateway of data, local process, filter data before sending to the cloud. The gateway can provide a lot of different things, but remember, simplistic gateway don't have a lot of resources. I don't know if you have the opportunity to try to use the firewall capability of your router in your home. If you create a lot of rules, for example, in your router, the performance of your router decreases a lot. It sometimes is freezing, you need to reset. It's the reason that a lot of people don't use the features of the security features that the routers, the internet routers provide. Most of the time use a different, or if you need security, you buy a specific router that has more power, capabilities. The IoT is a little different. It's a component that exists in the cloud technology, not only about the IoT, it's about the cloud computing. You have another one that is fog, but the fog is more, is a Cisco definition. To use fog, you need to have a big IoT implementation, okay? It's not the case of a lot of people, but a lot of people use, okay? And here you have a video that I try to explain what is the edge computing.
As IoT and digitalization of business grow, there are increasing challenges of managing large amounts of data. Edge computing will be required to support this growing data load. Gartner predicts that by 2025, 75% of enterprise-generated data will be created and processed outside the cloud. Today, it's around 10%. The problem is that when being processed in the company's data centers and in the cloud, the network bandwidth reaches the limit, producing data agglomeration, slow response time, and excessive costs. How can companies solve it? And why should they do it? Edge computing enables data produced by IoT devices to be processed closer to where it was created, rather than send over long journeys to reach data centers and clouds. Instead of traveling to the cloud, data is processed, analyzed, and filtered directly on or near the device. Edge computing allows companies, governments, and organizations to obtain numerous benefits, such as real-time data analysis, greater security and privacy, latency reduction, lower bandwidth consumption, less data storage in the cloud and company servers, lower energy consumption, fewer bottlenecks in data traffic. Let's take a look at some use cases. Latency reduction. Edge computing enables increased processing speed to respond to changes in situations, such as biometric monitoring of health issues, automated control of drones or other situations that require under 10 milliseconds latency. Bandwidth and data filtering. You do not need to send all the data. You only send what is important. An edge device is able to filter everything but important data and send alerts to centralized data centers reporting the problem. This is a more efficient model. Take the next step in your digital transformation. Vantic. Innovate faster. Operate smarter.
Okay. Again, when we talk about the edge device, it's a real powerful device. Okay, it's not like a router in your home. It's a device that has more capabilities. It's a professional device that you use in the real implementation of IoT in large scale, for example, in the smart grids or in the industry. So it's an example. You use, for example, in Microsoft, you have Azure IoT Edge runtime that provides a lot of services, very advanced service inside the company. For example, you have this device inside the industry and transform this data to send to the cloud. Okay. In this example here, you don't, give me a second. In this example here, for example, you didn't see in this example, for example, the gateway, because the IoT Edge device works like a gateway. Okay, things in this situation is, if you have a gateway, when you talk gateway, you talk of one device like the router that you have in your home. When you talk about the edge, you talk a device that provides the same service that a gateway provides, but much more. Okay. Again, the edge device is located closer to the data source. Okay. Again, the last picture. The edge device is in the industry. Okay, it's in the place where you install the sensor. It's not far. If you have, for example, three plants of your industry, you have most of the time 3 edge devices. Okay. The main service that the edge provides is only the large chunk of data really needed to power of the cloud to be processed are forward there. Okay, what it means? You don't send all the data that you produce, you send only the data that is important to the cloud nodes. The other data you store locally in the edge device and you process locally. Okay. Another important thing is the security. The edge device works like a firewall, protect the IoT network to the threats from the internet. Some benefits: decrease the network load in the cloud, reduce the transmission cost, provide a real-time response to the things because it's close to the device, it's close to the things. For example, you detect one attack, you generate immediately the action to protect the device. And provide monitoring of IoT device and their activities, okay? Because it's close to the device, it's not far than the device. Finally, you have the last layer, that is data center or cloud. The cloud, you have the management service, you have the advanced service. For example, you have a device in one plant of the industry. You have another plant where you have another device. In the cloud, you have the managed service that you manage not only one edge device, one plant, but manage all the plants, including in the data center or in the cloud, you integrate with the SAP or the enterprise other service, like the billing, like, for example, the DNS and others. Remember that the cloud is the brain of the IoT. If you have advanced algorithms in your IoT system, like, for example, machine learning, it is in the cloud, it's not in the plane, okay? You can store, process, and analyze massive volume of data. The edge provides some protection to don't send data to the cloud. But things, for example, a big implementation of IoT that involve a lot of plants, industry plants, the cloud receives a lot of data, and the cloud has features to process these large amounts of data, okay, the big data. You have different types of cloud. One of them is the public cloud infrastructure, like the Amazon, okay? The Amazon is a good example of the public cloud infrastructure. You have a hybrid cloud infrastructure. It's a type of infrastructure, a type of cloud that involves the public and the private. The private is a cloud that only your company works or only your company has access, okay? The public cloud infrastructure can provide the hybrid cloud infrastructure. For example, you can create a private cloud inside the public cloud, and the name is hybrid. The community is a cloud, it's a type of cloud that don't have cores, okay? That is to, for example, the government and others. Another important thing is the virtualization, okay? The cloud requires virtualization. What is virtualization? For example, you have your computer, I have my computer, but for example, you install one computer in your home to save information, save data information save the information that you collect, for example. Okay? The problem is when the space of your computer is finished, you need to buy another computer. Or in other case, that is the worst situation. If you have one computer and you have 80% of these computers is you don't use, you cannot do nothing. You cannot share this computer with your other company. Okay? With virtualization, you can create a lot of computers in the same a lot of virtual computers in the same physical computers, and you have more powerful and more. You use better your infrastructure. There are 4 types of the cloud-based service models. The first one is the infrastructure as a service, the platform as a service, the software as a service, and desktop as a service. The infrastructure as a service, yes, allows delivering computer infrastructure on outsource basis. For example, I believe this example here is good. Each on-site, it's your computer, okay? You have a computer that has our application. When you use this type of infrastructure as a service, you use, for example, the cloud. You buy, for example, you create an account, for example, in the Azure, the Microsoft Azure, and create a server inside the Azure, okay? In this case, you get your physical servers, okay, your hardware, and don't use anymore the hardware. You install the same things in the cloud, okay? It's like you install a server like Ubuntu or Windows in the cloud. The next example is the platform as a service. It's a little different, okay? You don't use, for example, it's like Gmail, okay? Gmail is an example of application as a service or platform as a service, okay? You have you don't use the server. For example, when you buy, for example, Outlook, you can buy, for example, for your company, Outlook in the cloud, okay? And you create a virtual Outlook in the cloud. You don't handle, for example, the Windows. You don't know if this service is running in the Linux. It don't matter. You buy a service. And the last one is the service is a cloud, where is the last part. One example, it's easy to understand using it. For example, when you use IaaS, you use, for example, you install a complete server, you install a Linux, you install a Windows. When you think about the IaaS management, it's like a GitHub implementation, a GitLab implementation, okay? You don't worry, you use the GitHub. The GitHub is an application that you have in the cloud. The Docker is another application that you have in the cloud. And in the SAA, you don't use, for example, how you use GitHub? You can use GitHub in the multiple ways. You can use GitHub to manage a project. You can use the GitHub to store your projects. You can use in multiple ways. When you use the SaaS, it's different. You use a specific set like the Verizon. Verizon is like oh my gosh, the telephone company is like oh my gosh, I have one account from Mexico. It's like AT&T. It's like AT&T in the Mexico. Okay, you buy a AT&T service. For example, you have a mail. You buy a service. You buy a service. You don't buy a platform. For example, in the GitHub is a platform. You can do multiple things. No, the SaaS is like you buy a service, like, for example, the email. Okay. The last way to use the service in the clouds is the desktop. For example, it's you want to don't have for example, you work here today in Brazil in my computer, but for example, tomorrow I will be in Mexico and I don't want to use my physical computer. I want to enter in the Mexico, for example, in the tech, log in any machine in the tech, and my desktop appears for me. Okay, because my desktop is not anymore a physical desktop, is in the cloud. I can connect with any place that I want, and I have my desktop. Any question, guys? Did you understand?
Yes.
Yes,
Okay. Some examples of it's really new. Okay, the desktop as a service is really new. You have the Amazon Workspace, VMware Warzone, and Microsoft Azure Virtual Desktop. It's not so common to find because it requires all the times a good connections. Okay, and a lot of people prefer to use a laptop to have your personal desktop. I use this technology, for example, in a very specific application. Okay, in a very specific application, I have one application where your user cannot change. For example, I use this implementation in a specific application that your user do not change the desktop. Is all the time the desktop is the same. Okay, the user only use the desktop. Okay, and when the user change something, I reset one button and everything back to the previous configuration. Okay, it's a very nice application for a very critical desktop that you need to have a very secured and very specific configuration, but it's not useful to the normal situation. Okay. There are multiple different type of clouds. Okay. In our course, we use the IBM cloud. Why IBM cloud? The IBM cloud, we select IBM cloud because all of these clouds require some proof of identity, and all of them use the credit card to prove to perform this proof of identity. Okay, you need to have a credit card. I cannot ask you to use your credit card to have a course, okay, to academic course. IBM is the only solution that you don't need to use a credit card. You use your credentials from the tech, your accounts from the tech. You use to create an account in the IBM cloud, and you don't need to use a credit card. It's the reason that you use the IBM cloud in our course. Okay. In the general way, if you analyze all the clouds is the same to the basic functionality. It's changed when you use more advanced features. In this course, you use only the basic features. It's okay to use IBM, Google, Amazon, or Microsoft is the same. Okay. So we have this video. I cannot remember how many minutes. Yes, you can see this video. But before you see this video, did you see my screen?
Sí, profesor.
The canvas, yes, no? Okay. In the canvas, I will publish these activities. It's not published yet, okay? Because it's not published because I need to create the groups in the canvas, okay? It's the only reason. But I will publish today, maybe 1 hour after we finish the class, this activity, okay? In this activity, you need to read this material. What is a smart home, okay? It's a PDF that I prepared. Oh, gosh. Open here, it's much better. Open. Yes, it is a PDF that I prepared, okay? That explain what is a smart home, the device that you have in the smart home, okay? Rules, what you need to do. You read this material, map the features that this common house needs to have, okay? Find in the internet, the real internet IoT device that you can use to automate this house. Read the data sheets of the found device and use the architecture that I present, okay, this one, to design one architecture about the IoT and generate one small report, 3 pages, no more than it, okay? With introduction, development, file remix, and reference, okay? It is through October 3rd, okay? I will publish today, I will publish today this activity, okay? It is a group activity, it's not an individual activity, okay? I will publish until the end. In more 1 2 hours, I publish these activities to do, okay? Any questions?
No, okay.
Okay, back to the video.
Today's top 3 tech giants, that is Amazon, Microsoft and Google, have their own cloud platforms out there. And their names are Amazon Web Services, Microsoft Azure and Google Cloud Platform. Hey guys, this is Shubham from Intellipath, and in this video, I'm going to compare 3 of these cloud giants and discuss which one to choose. So, without any further delays, let's get started. Let us just start from the basic and discuss each service in a brief. Amazon Web Services is the oldest and the most experienced player in the market, as it was established at the beginning of 2006. AWS has an extensive list of computing services with functions of deployments, mobile networking, databases, storage, security, and many more. Whereas Microsoft Azure was presented in February 2010, and since then it has shown a great promise among its rivals. This platform can easily be associated with AWS, and both provide their customers with a full set of services in the domains of compute, storage, database, networking, and many more, just like AWS. On the other hand, Google Cloud Platform began their journey on October 6, 2011, and by this time they have managed to create a good presence in the industry. Initially, the push was to strengthen their own services such as Google or YouTube. But now they have moved further and they have also created the enterprises services. So now anyone can use their cloud platform, which shares the same infrastructure that of Google Search and YouTube. But still, the question remains, how are these 3 cloud services different, and what are the factors that we need to focus on while comparing 3 of these services? Well, we are about to discuss that as we move forward. Let's just start from the first factor, that is the availability zones. Before discussing this factor, let me give you a brief introduction to availability zones. Availability zones are the isolated locations within data centers regions, from which public cloud services originate and operate, and the regions are the geographic locations in the data centers where public cloud service providers reside. Basically, businesses which are using cloud choose one or multiple worldwide availability zones for their services depending on their business needs. So they select the availability zones for a variety of reasons, including compliance and providing proximities to end customers. Cloud administrators can also choose to replicate services across multiple availability zones to decrease latency as well as to protect their resources. Admins can move their resources to another availability zones in the event of blackout. Certain cloud services may also be limited to particular regions or availability zones. So now we are all aware of their establishments. We all know that AWS was the first one of its kind, right? Which means AWS is hosting in multiple locations worldwide. And of course, it is true for Azure as well as for Google. But here also, the difference occurs in the numbers of regions and availability zones. Talking of number, AWS has 55 availability zones worldwide with 8 more on its way. Whereas Azure is having 44 availability zones with a whopping number of 12 more on the way. On the other hand, Google is having 18 availability zones with the 3 more on the way, which is no doubt is quite a lesser number than AWS and Azure. Now let's move forward and talk about the next factor, which is the market share. So guys, if we check this graph right here, which clearly depicts that how AWS is leading with 40% of public cloud market shares worldwide on its name, whereas Azure is on the second place with 30% of the market share, and Google Cloud, which is not that behind, is on third place with 10% of the market share, and other cloud providers combines at 20% of it. And guys, let me tell you an interesting fact here, that according to a recent report by KeyBank, Amazon lost almost 6% share while Microsoft Azure moved from 26% to 30%, and Google successfully jumped its share from 8% to 10% in the cloud business. Also, if you check the Google Trends graph and compare their popularity, these are the stats where you can easily figure out that how interest for AWS has been surpassing with Azure on second place and Google on the third worldwide in the past 12 months. Even if we check the research results and trends according to USA, same cases here as well, where there is more interest for AWS than Azure and Google Cloud. In case of India, here are the results. Still, AWS is more trending. These are the results from past 12 months and have been varying and relatively increasing, with AWS on the first and Azure on second, Google Cloud on third from a past decade. We are all aware about the establishment of AWS now as a first cloud provider, right? And with the more experience and implementation in the cloud domain, it obviously has a bigger community support and trust across its clients. And with Azure and Google Cloud, well, they have been able to cop up trust across their multiple clients successfully. So let's check what type of companies are using them. AWS is having more profile customers like Netflix, Airbnb, BMW, Unilever, Samsung, Xiaomi, Zynga, etc. And Azure is also not that behind, as almost 80% of Fortune 500 companies have put their faith in Azure recently. Some of its major clients are Johnson Controls, Polycom, Fujifilm, HP, Honeywell, Apple, etc. Since Google shares the same infrastructure that of Google search engine and YouTube, that is why many huge companies are having faith on them. And some of their major clients are HSBC, PayPal, 20th Century Fox, Bloomberg, Target, Domino's, etc. No doubt AWS is dominating public cloud over Microsoft Azure and Google in this race, but they both are also growing continuously to be at the top. So guys, don't you think it is quite impressive for Azure and Google to be on the top runner list even after being a latecomer in the cloud domain? Right. Now, after discussing their establishment in the market, let's talk about what each provider has to offer in terms of services. So guys, the services which I'm going to compare here are very primary and comes under the following domains. That is the compute, database, storage, troubleshooting and monitoring. So AWS covers like 200 plus services and Azure also covers 100 plus of it, whereas Google Cloud have been catching up with it with a number of 60 plus services. So now let us compare the primary services in each of these domains. I'm not covering all of these services since there are so many services in each of these domains. So in the compute domain, the primary service offered by AWS is EC2. In Azure, it's virtual machine and cloud engine for Google. So basically all these three services help you in launching instance on cloud. Like if you want to run a virtual machine or an operating system without an on-premise infrastructure, you can do so with any of these services. They all have the same idea, same working with the same functionality. Just the names are different. But there is one major difference, that is the speed of launching an instance. Well, if you try to launch an instance in three of them, AWS will take around a minute to launch an instance. In case of Azure, it takes more time to do so. But guys, in case of Google Cloud Platform, well, it takes seconds to launch an instance. This is where compute engine comes out to be a preferable choice. Now, another service comes under database domain. The primary database service provided by AWS is RDS. That is a relational database service where the databases like MySQL, MariaDB, Oracle, which can be managed automatically, like backup, security patches and updates are done automatically by RDS. In case of Azure, there is a primary service called as SQL database service. Well, in this service, you cannot choose any like MariaDB, Oracle or MySQL databases. So you can only choose SQL database. And you need to change your application code to be compatible with SQL databases if you are using Azure. Even you have to configure everything on your own. No automated updates facilities here. Now in case of Google, we have the service named as SQL database, wherein you don't have the provision of choosing any other database apart from MySQL database and PostgreSQL. Now let's discuss the next domain, that is the storage domain. The primary service in AWS storage is S3. So this is the simple storage service, which is an object-based file system. So whenever you are storing your file on these systems, these files can be treated as an object, and S3 consists of buckets, which further consist of root folder, and one can store their objects inside these root folders. And Azure on the other hand implemented this similar idea. its primary storage service named as blob storage, which is an object-based file system where the files are stored as an object. Well, in case of Google, cloud storage is the service, and again which provides you the similar kind of object-based storage system. Moving forward with the another domain, that is the troubleshooting. The primary service provided by AWS is CloudTrail. CloudTrail is a logging service. Any deployed apps on AWS with the API calls, those API calls gets recorded in the logs of AWS, and then it helps you to troubleshoot your application. Suppose if there is an error, you can easily troubleshoot the specific part of that failure in your application. Such operations can be done using the logs which get stored in your AWS. And in case of Azure, you have Azure Operational Insights, which provides you the similar service that of AWS if you have your application deployed on Azure with the API calls. Similarly, in case of GCP, we have Stack Driver Logging, which again provides you the same functionalities. Our next and last domain is monitoring. Well, in case of monitoring, the only service offered by AWS is CloudWatch. Using this service, you can easily monitor each and every resource or service running in your AWS account. It provides you very basic information like the amount of traffic coming to your instance, what kind of traffic is connecting to your instance, the performance of your instance, etc. You can manage, control and monitor all of them using AWS CloudWatch. And Azure on the other hand provides you a similar service called as Azure Application Insight, which does the exact and the same operation just like AWS CloudWatch. Also, Google provides you Stack Driver Monitoring service, which again performs the same and exact operation that of AWS CloudWatch. Now the another factor is its downtime. Having a matured infrastructure, the maximum downtime faced by AWS in 2014 was of 2 hours and 69 minutes. And whereas in case of Azure, even after having a good infrastructure, they faced a huge downtime of 39.77 hours. And Google on the other hand just faced a downtime of 14 minutes and resumed its services in no time, which is actually impressive for a newcomer like Google Cloud Platform. Now let's move ahead and check their pricing and billing models. In case of AWS, a very basic instance which includes 2 virtual CPUs and 8 GB of RAM will cost you around $69 per month. In case of Azure, it will cost you around $70 per month. And when compared to GCP with 25% cheaper rate, it will cost you around $52 per month. Now the largest instance offered by AWS is of 3.84 TB of RAM along with 128 virtual CPUs, which will cost you around $3.97 per hour. Azure on the other hand offers 3.89 TB along with 128 virtual CPUs, which cost you around $6.79 per hour. And in case of Google, this is where Google takes the lead with a whopping number of 160 virtual CPUs with a 3.75 TB of RAM, which will cost you around $5.32 per hour, which I believe is much cheaper in terms of virtual CPUs provisioning as compared to AWS and Azure, right? Moving forward, AWS provides you reserved instances. For example, the company purchases the instance for contract prices, where instances are available in various levels of compute power, and if a company buys them for a particular year, like this could be for 1 to 3 years contract, then they will get a 70% discount. This is how it works, right? So now previously AWS used to charge on per hourly basis.
Guys, I need to stop